Kindly wait please 1 minute so more participants can join. Then we will be start.
Hello.
Very good evening to all. I am audible to all. Please verify. Okay. So first of all, I'm very thankful toward all the participants who joined this session. And in our previous session, we have discussed about the rescue software. My colleague Ujjwal, they discussed about the rescue software and their overview. So in this session, we will be discussing about the NanoDCAL software. Generally, rescue and NanoDCALs, they have some same features, but rescue software is generally used for the material simulations. But NanoDCAL software used for the material and device simulations. So in this sessions, the third day, we will be discussed about the NanoDCAL softwares which work for the material and device simulations parts. So it is the third day. You can see now we will be create the two provide device structures. I also saw the four probe device structures, and we will be discuss how we can create two probe device using nanodecals that work non-equilibrium green functions plus DFT formalism, and it have the two probe structures like left and right electrode plus scattering regions. We have also front and back electrodes and top and bottom electrodes. So that's six probe structures we can create. Molecular device like benzene between metal electrodes that we have already created in the previous sessions. Key transport parameters, transmissions, LDOS, effective potentials. How we can calculate this property we will be seeing in these sessions, and we will be create two probe device structures. In here, the some examples that attach in here, it is the graphene structures where I have the left leads and central regions with right leads. A calculated transmission spectrum, density of states, effective potentials, and projected density of states. So in the next slides, it is the nanodecals, some of things that we have attached. It is a small PPT part, so it generally overview of the nanodecals, like it is written in the MATLAB plus some C. Standard user-based product, 100 of publications that are present, I will show in the last parts. Focus on electronic and spin transports, IV characteristics. We have also includes effect of the gate, dielectric, spintronics, collinear and non-collinear. Common analysis tools like DOS, PDOS, LDOS, band structures like this, and thermal transport tools and Kunon tools. Some of the graphs that we have attached, and it is some of the papers that published on the nanodecals. You can check on the Google Scholar also. And in we have that software NanoDCAL Plus, like NanoDCALs and NanoDCAL Plus. That are the advanced versions of the NanoDCALs. They have difference. It is written in the Python plus Fortran versions. Solve small to large scale systems. Provide enhanced modularity interface with third-party tools. Improve parallelism, hardware portability, and performance. They generally focus on the parallelism, hardware portability, like these terms, and spintronics and semiconductor nanoelectronics the same, but work for the 10K plus atoms. Like this, you can see large molecules. Some of the atomistic products summary like given, and the difference that's showing in the NanoDCAL plus rescue and NanoDCAL plus rescue plus. You can see NanoDCALs we have calculated and working on the photocurrent also, thermal transport, Kunon tools, complex band structure, multi-probe transports, and bend device. We can also create bend type device structures. NanoDCALs plus we have that properties. Rescue, they have some difference. Generally, NanoDCAL and rescue, they have same features, but only difference for the material simulation that come across at the rescue softwares, and NanoDCAL we have calculated material plus device also. Now it is a small PPT. Now I'm going to show the device studio where we can create the device. You can open with create a new projects and providing here the new names like this, and you can save. In our previous sessions, we have discussed about these tabs, how we can use, how we can find, and how we can analysis. So we are not discussed about these parts. We are directly calculate their properties, how we can create device. So I hope you have all the installed device studio software. If you have not installed anyone, that's of Device Studio. So if you have not installed the Device Studio, so you can contact us after the sessions. Generally, we are working on the 2 or 3 days, so you can contact us. So everyone open that Device Studio, who have installed that software. Please verify it. Okay. Okay. So we will be click at the file options. You can see number of the options. We can give the one overview: new project, open project, save projects, and new device, crystal, and molecules, and we can import. So we have discussed in our previous sessions. We can directly move toward the imports parts and move toward the import locals. We are going to create in here two probe device structures. So simply click at the import local, and 0D, 1D materials, 2D materials, 3D materials, and organic material are available. Like you can check molecules. Who has not seen it previous sessions, you can see. Same for the 1D, same for the 2D, same for the 3D. Like you can see number of the semiconductors and magnetic materials, conductors, you can see. And in here, different formats are supported: HZW, XYZ, CIF. You can directly import your file through the Google's and any online websites if they supported that formats. So you can also directly import and you can create your own supercells. We are going to select in here gold AU. You can select and just click at the open. So everyone had created and selected this AU elements. So now we are going to create in that tab. You can see, I hope everyone selected that elements. Molecule 2D decompositions. That tab we have already discussed, and you can move toward the redefined crystal tabs. In the build tabs, you can select that redefined crystals. In here, you can create the supercells and redefine that simple unit cells to large structures or supercells like this. If you click on the preview, you can increase it at the C directions like this. Simply click at the face center tabs and preview. You can click at the face center, then click at the preview. Please follow that steps so it will be easy for you and you are able to create the two probe device structure by your own selves. Anybody have the confusion related to this, please ask in the comment box and you can directly unmute yourselves and ask me. And then click at the preview, and after that global Krishnan we search asking that why doing these steps only face center or body center, why selecting. So sir, generally we have followed the example portions to understand you. It generally user defined. If person want to move toward the body center, you can follow that step also. If you want to redefine with these steps, you can follow that step. It is a user defined, sir. Right, sir? So we are just follow the steps. And then click at the preview, and then you can move toward the build. I hope everyone completed this. And then build the tabs. Now you can see, you can move toward with click at that left and mouse, you can see. Everyone created this. Now if you want to increase more and more, create like the super cells. So again you can move toward the build parts, and then again you can move toward the redefined form.
Sir, please repeat this.
Okay. Like you first you selected that AU elements conductor, and you can move toward that build form, and then you can move toward the redefined crystal form, and you can select that phase center, sir, like this, and then you can click the preview, right, sir?
Okay, sir.
Just
Okay.
click at the build. Okay.
Thank you.
So everyone have completed that tabs, and then you need to move again build option, because we are going to create in here the supercell types. Again you can move toward the redefine crystal form, click the redefine. Now you can increase that directions with respect to the example that you are asking. We are just follow the example point of view and their parameters. It is a user defined parameters, so it totally depend on you. We can move select at here the 2 and 4, and you can check in here the preview like this. If you are selected in here the different portions, so number of the atoms also increases and structure will change. It is just a supercells, you can see. You can select in here the 4. Everyone selected the tabs 2 to 4, and just click the preview, and then you can click the build portions, right? Everyone created that redefine and redefine that XW text files. If not created, then please ask me, and otherwise I will move toward forwards. So you can also go with these tabs like different view, like XY view, XZ view, and YZ view, and ZX view. Like this you can see. So at that you selected that XY view. Here the A, C, and B, you can see that vector are selected. So you can move toward the XY view. Please select the tabs. XY view and then select. After that, you need to create that type of AU and their supercell. You need to delete at topmost elements. Select that like this XY view, and you need to click at the right side of mouse and hold it, and then select that topmost AU and click at here the delete tabs like this. Please follow that steps. Same for you can select at the this sides BC form, and then you can delete that also like this. Please follow that step also. First delete that tabs, and then you can delete that tabs. Okay. Everyone completed that? After the completion of these types, you can move toward the again that view. Samran Majmoor sir asking that why are we deleting these atoms? Sir, just we are going to create one of that electrode like AU forms. So we follow the step of the examples. Like you can see, total number of atoms are 36 and total area of the lattice that. So we are just creating one of the AU left electrode, one of the biphenyl molecule scatterings, and then other AU. So it is user defined. We are follow the examples. If you want to select different XY view, different XZ view, so you can also choose that tabs. You can create your own device by or own parameters. We are just follow the examples for your understandings. So everyone can cover the same steps, right, sir? Okay. You can create with that ZX view. Please click that ZX view. So you can see that type of ABC. How holding strength of these atoms? Gopal Krishnan are asking how holding strength of these atoms when current applied. How to design atoms? So generally, it is a just of the redefined crystal forms. It is not a form of device. When we move toward that tab after the device, then we will find the analysis, currents, IVR, different things. It is just one of the crystals that we have selected. It is not a device now, right now. So click at that ZX view like this, and when you completed that type of steps, now you need to delete some of the atoms. So same type of things that you can give in another forms, like we just select that 3 elements. Please select these and then click at the deletes. After the select that elements, after deleting of this, you need to delete that atoms. Simply click at the deletes like this. Then select again these. Please create that type of that form. It for the easy, you can count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now we can move toward the crystal forms in here after the completing of these steps. Because we need to create in here the vacuums, you can also create and you can convert the crystal form also. With same type of structures you can create after that. Please click at that convert to crystal forms. It is just unit cells, so you can convert in the crystal forms. It is a primary vector, you can see. You can give in here the value for the primary vectors 20.
Sir, excuse me.
Yes, sir, please ask.
Sir, how you choose convert to crystal?
Sir, just convert to crystals. You like you can see it is just a unit cells. When you create the convert to crystal form, you can see at the top side lattice, Breville lattice. When you select that cubic simples, cubic face centers, body centers, so different crystal form you can convert. But if you want to choose user defined options, so it will be totally depend on you. Like if you want to give in here the 20 value, you can give. If you want to create hexagonal type of structures, you can directly move toward that parts. And simple face centers. If you are selecting that user, yes sir.
No, how did you go to convert to crystal, that icon?
Oh,
Where
okay.
did you get that one?
Right, ma'am, that tabs. Convert to
Oh,
crystal.
okay, thank you. Thank you. Thank you.
Okay. Please show again
So
how.
can you
So
please repeat which how to
yes, yes, ma'am. Yes, sir. You can move toward that convert to crystal forms like this.
okay, thank
Right?
you, thank you.
Okay. Goba Krishnan sir asking why only giving this value 20. Sir, I'm again telling you that it is just a user defined option there we have selected. Therefore, I'm just follow the example value. If you are the users, you want to create different device, you can select in here the different vectors. For the large participants, I am considering one of the same value. I'm just going to tell about the how we can create one of the device. At the same criteria, you can follow and you can create your own device. If you are selecting here the cubic simple face center, body centers, you can select in here the lattice. If I'm selected the user defined, you can give in here that value. And in here you can give the vectors because 20, like if it is a simple unit cells, we need to cover the two probe device structure. Therefore, I'm going to move in here that new value 20. Okay. You can give in here the 20 value. And you can also give in here the 20. Automatically in here you can see that selected value, so 16.3132. So everyone select please that value 20 and it will automatically come at the 16.3132. If you have completed this, so we can move forward ahead. After this, provide that value, you can move toward that build tabs and simply select that tabs like this. It is the, you can see it is outside of the tab. If you can move toward the center tabs, the different tabs are given like center along A, you can move toward the center along A, center along B like this. You can select that tab also, that tab, center along A and center along B like this. After the completion of these steps, you need to select that whole tab like this. Please select all the atoms. You can see that mirror options, mirror atom. We are selecting that mirror atom options because we need to, we want the same type of structures and we don't want to create again this type of supercells. So you can same mirror type of structures you can create. Like normal vectors we have selected. In here the plane that we have selected in here the xy, therefore we are choosing xy. And this distance that we want to create, like we can choose any distance, but we can select Please provide that value. Like this. You can select that copy tabs and you can apply. If everyone selected that, you can select. And apply that tabs. You can see that same type of structures that come. Sir is asking what is the value. 1 minute. Please select that tabs. Move toward the mirror atoms. That y planes vector we have already selected in here, xy. You can give in here the distance. Which distance you have selected, the same structure, consider the same distance. Please give that value. Yeah, it okay if you are selecting 6, it's okay, not to worry about this. And you can click in here the apply, like this. So if you are not selected that mirror atom tabs, so again you can follow that same steps. So sometime it may be a issue. So NanoDCAL in the device studio, that options available. So same type if you want to consider. So just go with the mirror tabs and create the same structures. Now you can select these value and move toward the convert to crystals. Select all the atoms and move toward the convert to crystals, like you can see. Please select that, only that you can select. We have already selected that. Convert to the crystals. Give in here that value. Like this. It is a too much far direction, so you can move toward this form. You can this value.
Can you please repeat this one once more?
Okay. Please select that. Wait 1 minute. I'm against. Please select that we have created mirror atoms. Go with these crystals. Again, you can go down. Select in here the 39. We have just followed the example value because we want to put that in the centers, in the Z directions. We have selected like this. They come in here. Okay. So everyone completed this? You can also click in here the center, so they will come on the center tab. Okay. After that completed that redefined form, you have two options. If you are going to create the biphenyls, so we can directly create the biphenyls, and if you want to import phenyls, we have also supported that import options and CIF files, so you can also import from the outside, like these download tabs if they available. Like if you want to import that gallium arsenide, yeah, anything is, so that's supported. But if you want to create by own one of the molecules, you can also create. So I'm going to create one of the molecules. Go with the build tab and select the molecule 2D and select that cyclohexane type, draw like this. And you can select that draw singles, select that carbon atoms. We need to select that. Please follow that steps. Move toward that cyclohexane. Once again, select that line like this. We have already selected that carbon like this. Please create like this. So next step I will tell them. From here, did you select the carbon, sir? You are asking, sir, we have already that carbon in the top side. You just click the cyclohexane and then line tab, and then just hold that, and you can move toward this. Like if you see, like this. Hold the right button of the mouse and just leave it. Please ask if anybody not completed these steps. So, okay. Now you can create in there the next, click at the choose elements like this. You can select hydrogens because we need to change in here like this. Please click at the carbons like this. Only click at the carbon atoms, and otherwise it will select the different one, because we are going to replace only carbon like this. Follow that steps. If anybody have the confusion, please ask. Okay, we move ahead. Like you can see that is not showing the line properly. Sir is asking. 1 minute, I will tell you again. Please select that first, sir, like this. Then just move toward this line, draw singles again, and select that and just hold the mouse and go drop at the up sides and leave it like this. We have already selected, so it is come like this. The line, if you are drag too much, so it will look like this, but you can move the simple point to point, you can get accurate. You can also see in here that hydrogen, add implicit hydrogen, remove implicit hydrogen. Number of people asking about the charge. So in here some charge options are available, but we just move toward that apply data like this. You can see that structures. It is simple. You can see the force, UFF, GFF, chemicals, and different force. For inorganic, organics, you can simply move toward the GFF like this. Now you can see that molecules. If anybody have confusion,
Okay.
yes sir, please.
Sir, can you repeat this? How you show the structure?
Okay, sir.
Sir, how you have replaced CH3 by hydrogen atom? Please show it again.
Okay, sir. I will definitely show you. Move toward the build tabs, molecule 2D. You can see the cyclohexanes. Please select this. You can see in here the carbon and in the single lines. First, you need to click the draw singles, drag it, not too much, but drag it point to points like this. You can see. Now, people asking how we can change that carbon to C. You can see that carbon. Choose elements, select the hydrogen. Remove that. Only need to select that carbon.
Hello, sir.
And then, yes, sir, please.
Sorry to disturb you. Sir, actually, how to delete some other elements if we have wrongly click on the whiteboard?
If you click, you can
Yes.
undo or redo options available. You can also cut that, select,
that.
and
Okay,
you
okay.
can, okay.
Okay, boss, thank you.
Okay. And simply click only the carbon because you are going to replace carbon like this. Like this. You can also move toward that cut tabs. You can cross that like this. Now people, participants have completed this structure, so we can move ahead. In the molecule 2D, number of the options are available, so you can create different molecule structures. If you are repeating these structures, so it will be easy for you. First time it can be a difficult for you, but if you are able to handle one of the structures, so you can create different structures. And then you can click the apply data. I hope everyone have completed these structures. So we can move ahead.
Sir, how did you create a structure? Just the atomic structure bonded to.
You are asking about the same structure or different one?
No. You just show the structure with some atoms just before
Like,
that.
just before that, you want to see the different molecule structure, right?
Yes, sir.
Okay, sir. 1 minute. You can click in here the apply data. You can see that structures.
Okay.
First, you need to select that molecules, and someone want to ask the different molecule structures. You can move toward the builds, molecules. We have also in the imports data different molecules, but if you want to see in here that, you can see that's structures. And if you want to create by your own cells, you can also create. And in here the difference dihedral want to replace like manganese, you can see different formats are available. Like if I select this, you can click, you can create like this. So it just for the create the new molecules or that type of molecules wants. And if you want to import molecules, you can directly import online. And some of the molecules you can see phenyls. Like if I selected that, you can see. If I selected another, so some of the library are available for the molecules. Like this. Okay, sir. And you can also import online if some of that
Thank you.
library are available. Okay. So we have completed this. I hope everyone completed that and follow that steps and reach in here. Then you can click in here the convert to crystals because it has simple molecules structures. You can see that vectors we have selected and simple click in here the build tabs. Now it is form of the crystals. Like if you want to replace or change some things, you can change like this XY view or different view you can select. Now please select that whole benzenes. We are created the one of the biphenyls types. So please select and click in here the mirror atoms. Please select the XY view. And you can also take in here the different directions like 5 and then apply. Please follow that steps.
So how you select the mirror
Ah.
configuration?
Yeah, so it is that tabs mirror atoms in the rotation in the after the rotate atom you can see mirror atom tabs, and we have just selected the normal vectors because we have chosen that XY view. That's why we have selected XY, and you can choose the distance, so it will make some distance for these molecules. Therefore we have selected the distance. You can choose any distance, but it will be some respective distance between these molecules. Please select and you can click in here the apply options. So I hope everyone completed this step and you can create that molecules. Now you can see this type of molecules. How did you bring that ring from 2D to studio? Vinod Basnes are asking. Sir, when you have created that molecules, through that molecule 2D, in here the applied data forms are given. So just create that molecules and you can click in here the apply data and it will come then. Okay, sir? Now you can see that molecules, but we need to create in here that biphenyls. So just we need to attach that molecules with most toward that structure in between. So first you can select XY and XZ, YZ. You can see the different forms XZ and XY. Please select that tabs, one of the molecules. 1 minute, 1 minute. First, you need to click XY view, and otherwise you will be confused. And then come like this. Please select XY view. Then in the same
Sir,
screen view, you can come.
I'm unable to get the mirror image of this molecule. When I click on the mirror image, but it is not generated.
1 minute, I will show. You selected that copy and apply. First, you need to select XY view, and then you need to select in here the 5, sir. Then you need to copy and then apply. Follow that step, sir. It will be
Sir,
complete.
icon of the mirror image is it gets blurred. There is no option to click on it.
Yes, sir. Same problem along with me.
So, sir, you need to connect with after the sessions because we are not aware of these things. Maybe it will be network issue, so you can cross the device studio and again open this, sir, and then follow the same steps. It will be follow the open and existing projects option you will be selected when you again open that device studio, sir. Okay, sir.
Okay.
Okay. And follow that same steps. I think it will be completed. Then same screen view. Click in here that rotation tabs. You can see rotate along screen vector. You need to select that. Please come on that tabs. At the same screen view and same structures, you can click in here the angle 15 you can take. Simple rotate like this. And then you can rotate like this. You can, it will totally depend on the users. So you can
So
come with
please
this type
repeat
of
this
step.
rotation tab. How you
Okay,
pick
okay.
this?
Okay, sir. Like first you need to select the XY view like this. You can rotate the tabs and come like this. It may be some difference, or you can choose wisely your parameters because we need to connect these molecules. So it will help you like this. If you are rotated like this, it will show different view, and when you like this, it has show the different view. So you can come like this view. You can see 2 and 2 and 2 like this. Same way you can select this. Like this. So just follow the any angles or any things, but you can come like this view. Gopal Krishna sir saying yes, completed. Please select that and click the move atom tabs like this. In here you also choose transitional along screen view.
Sir,
And
yesterday it worked, but today it is not working, sir. All options are blurred.
I think so you missed that one of things. You need to convert that crystal tabs up. First you need to click the convert to crystal and then build, and then you can select that benzene rings and you can click mirror atoms. Try one more times. Click that convert to crystals and then you can build, and then you can select that mirror atoms.
Yes, sir. After converting into crystal, it is working.
Okay. Okay, sir?
Yes, sir. Now it is working. Yes.
Oh, okay. Thank you. So just you need to come with this type of screen view. Select that atoms. You can move like this, this, close to this. Move back. You can delete that hydrogens. that hydrogen. You can again click that. You can choose one of that, some small distance. It's just for the moving. It totally in your decisions how you can close this type of structure, because we need to create in here the bonds like this. Hold that control button and click that the bond atom options. Now you can see it have the too much distance. So again you need to move with different one. Like this. Again you can come like this. You can rotate like this also. Follow that up portions, and you can also try by your own self, because it will be sometimes it can be a difficult because you are trying to first times. Again you can move toward the bond types. Like this, we need to create that type of bonds. So please try by your own selves, because I can't tell about that rotations because we can't see your systems, but you can use that rotation tabs and move atom tabs. You need to close that type of atoms firstly. Please try by your own selves. You need to delete one of the hydrogen, and you can see that screen view 2 2 and 2 2, and then delete that hydrogen, and you need to connect that bonds. Please try, because rotations and move atoms, it totally depend on you how you can do and how you can connect, because when it will be closed, then only that options will available for these atoms. Like this. Please follow that same screen view.
Sir, how to connect the atoms?
I'm telling about the same things, sir. You need to use that rotate atom tabs and move atom tabs.
Okay.
And try
atom.
to connect that same screen view, like you can see 1 2 1 2 1 2 1 2, and delete that one of the hydrogen and try to connect these with use that screen view or that tabs, screen vector, screen view. And it sometimes it can be a difficult, but you can try, because I'm not able to see your screens. So you need to close that atoms
Okay, sir.
like this, and you can move like this. Okay, sir? Because I'm not able to
Okay,
see
sir.
your
Thank you.
structure. Please try. If completed, so please tell me. Gopal Krishnanvi sir asking which button is clicked to connect both atoms, sir. You can see that to intermolecular connect that bonds, recalculate linker bonds. At the last step, you can see my screen. When it will be closed, then it will work. Okay. So follow that same scan view, same that tabs. You can connect this type of structure with this distance. So that is the steps you can follow. If you want to move with the singles benzene, you can also move. But for the biphenyls type of molecular structure or device structure that we are going to create, so therefore I'm follow that steps. So I hope everyone have completed this. So now I'm going to move ahead. Please select all that molecules. Okay. And move toward that. Redefine HZW and copy that, and then you can paste your that structures like this. Please follow that step. For me, it is heading not able to connecting these two atoms. Gopal sir, in AB, you can see there's two arrow type of drop down. You can see, please see my screen. You can see that two arrow. When you click that, you can see that intermolecule in recalculate linker bonds. And because sir you are not able to click that, sir, you can rotate your structure. You can see it will be too much distance, therefore it is not connecting. Again you can move that and closes that structures like this. You can see, you can rotate that, and you can see the distance between those two atoms. Please see distance between these two atoms. When it will be less, then it will be work. It will work only when it will be close that. You can rotate, you can try by your own cells, because using that move atom types and rotate atom types. When you are done this, then it will definitely work. Intermolecular linker bonds. So if you have completed that steps, please select that biphenyls and again move toward the center like this. Follow that steps. You can also click in here the zoom view like this. You can see like this. Follow that screen. Again, you can click that arrow. You can see that it have the different form. So now you again move that biphenyl structures. We need to also add nitrogens and different like AU, N, then biphenyls, AU electrode types. So first follow that step. After that, we will be connect with different one. You can select that biphenyls. Again, you can move toward the rotate atom tabs. Like you can move with this. You can see. Please follow that step and you can go with the same screen view like this. If you have completed that steps, you can again Binod Basnes are asking, how did you bring the structure here? So, sir, you need to move toward the molecules. You need to copy that molecules, Control and C, then select that AU, redefine, and paste your structures, Control plus V. And then you can move toward the center types. It is a center option, right? Everyone follow that steps. Okay, now I'm going need to move that forward. You can click that, and now I'm going to add in here the nitrogen atoms because we need to also connect that bonds with these molecules. You need to move that add atoms options plus simple select that nitrogen and then click the OK and click in here that nitrogen atoms. One minute, it have selected I think carbons. So again move toward the add atoms, select that nitrogen and OK. You can see in here that nitrogen atoms are come blue color. If the same, you can select add and gold. Please follow that steps. We need to connect these bonds. If someone have confusion regarding this, they are not able to connect, so please you can ask. same screen view, if you follow and only that move atoms, rotate atoms options you can choose, and you can arrange that structure with this same screen view. Now you can see, you can also move like this, and you can also able to see their distance. So it will be easy for you. Select that last AU nitrogen and click that. In here you can see only that will be selected, and it is not connected because it is of hard distance. And in here you can see two will be connected, so we need to disconnect this. So again, undo or redo options you can select like this. Again you need to select that, connect that bonds like this. When you rotated that screen, you are able to see like this. Select that whole AU and need to move some more distance. Having you can move like this some distance like this, because we want to, they're not connected with this, we only want to connect with only these, therefore we need to move some distance, so intermolecular bond that not connected these atoms. Again you need to choose that. They are again connecting, so again undo and redo. It's totally user defined, therefore I'm showing when we are creating the device we need to work on these move atoms and that tabs. You can move like this. Again you selected that, hold the control button, one by one select that. Now it is not connected with this, but it connected with this, so now we need to move that atoms. Again undo redo, and now you need to select only that atoms like this. Select that. You are able to need connect with the control button. Now you can see it will be connected only the seams. You can move like this. I hope you understand how you can connect this. Move atom and rotate atom will help on this. Now you need to connect these atoms. I think people are I think you are able to try these steps. Select with these atoms and click that intermolecular bond. It is not able to connect. Again you can see in here the too much distance between this. You need to move that distance upside some like this. Then again click the intermolecule. It is not connected again. You need to move again. Now you can see whole structure are connected. It totally need to move atoms and close to that distance, because we connect with these nitrogens hydrogens, NAU and AU, this type of structures you want. So if you want to create different structures in beyond this, you can also create like this. And it's just one of the examples that we have followed. So I hope everyone is trying this and view, YZ view, YX view. You can see different view. You can zoom like this. Now you can see. Cut that tabs. Again, you can move toward that center like this. If you follow, it will disconnect because we have moved toward this. Again, you can see. You can also move like this, the close. So bond will be strong, like arrow, like this. Move atoms like this. You can also select that, because after the connected the bond, you can arrange by your own cells. Some things that will be changed and something that will be arranged. I think everyone created that type of structures. Please verify it. You can ask if you have not created that structures. So let's move ahead. Like if you have created that type of structures, now you can move toward that device tabs. Select the left and select the right electrode. Five and 5. It is a left electrode tab with that directions and right electrode that with that multi-electrode device. The standard vector we have selected. When we click the preview, you can see that type of 2 probe device structure have completed. Then click at the build tabs. That device are completed. So everyone completed that type of device, I hope.
So please repeat this, how you build the device.
Okay, sir. When you completed that type of structures, just click to device options, convert to device, and select the left electrode, right electrode. It totally depends on you. You can change that value 5 and 5 like this, and click the preview options. If you're thinking that you want to increase more, so you can also select 6 any value, but we have selected only that, and then you can move toward the build tab, sir. Okay, sir.
Yeah, thank you.
Okay. Now you can see that device. After that, the device we have completed. Now we need to move toward the XCF inputs, NanoDCAL, software, tabs, and we can do analysis for this device. moves toward the simulator tabs, NanoDCALs. If we want to add buffer, want to increase that scattering regions, decrease the scattering regions, you can add. And virtual crystal approximation, it will be active for that dopings. And XCF calculation, you can see if you have created or relax or optimize your structures for the transistors, IV curves analysis, and that tabs are available. You need to move that XCF files first. Now it is user defined data, it is editables. So basic settings, electron temperatures, you can give energy cutoff. Here the unit you can see. Exchange correlations, different units are available. LDA, that the default value we have selected. Contour integrals value, just Rydberg and electron volts. So it is user defined data. Manoj Mishra sir asking, can you send this file so that we can move along with even these steps? So sir, we will provide that recordings, and you can also use that move atom and record tabs and mirror atom. Yeah. So you can got this. Please see this. And electrodes, counter integrals, I will provide the recordings also. Subras sir asking how you are choosing the value randomly. Are you following the examples? Sir, I'm following the one of the examples. It just for the NanoDCAL examples. That tutorial we have already told in the previous sessions. We just follow one of the examples. You can select any value. You can change. It is a table value. Like if you want to select 80, 90 or anything, you can select. You want to select in here the different value, you can select. Electrode voltage, you can select. Iteration control, density matrix, Hamilton matrix, total energy, mixed methods are available, linear quadratics, and okay sir. Broaden and that different formats are given. Hamiltonian matrix, density matrix, and real space density matrix are available. And it for the donator objects, basic sets. When we want to dope materials for the elemental atoms, Hubbard terms, where we can calculate for the transitions element and their calculations. Spin types, if we move toward the magnetic properties or IV or different charge type of properties, we can move toward this. Someone asking how to pick XCF calculations. So 1 minute I will tell you. After the selecting that, you can move toward the generate files. Now you can see. Sir, you can click the simulator tabs, NanoDCAL. You can see that XCF calculations, and you can take the default value, or if you want to change this type of value, you can change. Okay, sir. Abjit Danda sir is asking. Like XY view, ZX view, you can select. You can zoom like this. In here, you can see the device, XCF inputs, left electrode, XCF inputs, right electrode, XCF inputs. When we are running the device, you firstly need to run left electrode XCF input files, then right electrode XCF input files, then you need to move the device XCF input files. So first you can see and open with, you can see we have that setting that we have provided. System cell vector, we have chosen no spins. Iteration control settings, you can see, and atom for that blocks, left electrode, you can see, and that we have settings done. It is a tables. If you want to edit, and you can save. Same for the right, same for the device. Open and you can check for number of the left and right. When you run the left, when you run the right, then you can move toward the device option. So first you need to run left electrodes. Click and run tabs. You need to import in here that slum files. 1 minute. You can directly run if they are available, and we have that course, so we follow that steps. If you are running the NanoDCAL, so we run for the NanoDCAL. Then you can click the run. In the job manager portions, you can see our left electrode is running. Move toward the right electrodes. Simply click the run. You can see that right electrode is run. It will be the running and queue form. Same you can click and run. So when that completed left electrode, right electrode, they follow the device. We have already completed that results. So it will take some time because number of atoms are more. You can see 80 atoms are available. So in our your own systems, it will take some time. So it is still on the running conditions. You can again, I'm going to show this same projects with the results. Before the results, I will also tell about the analysis parts. You can see running left electrode, right electrode device. You can also move toward that analysis parts. You can see density of states. It is user defines, k-point sampling, number of energy points projected. If you want to select that, effective potentials, total scattering transmissions. So for transmission, it will take generally hundreds. Space grids, we have followed that criteria. And photocurrent and IV curve have different formats. Like first we need to calculate the charge or different potentials, conductance. Like we can select the some analysis part. You can see left electrode, right electrode. We are going with the device tabs. You can click the generate files. And then simply click at here the run. You can run all the files. If you are coming that, it will be okay. And otherwise, we have followed some criteria. Each of that files, you need to see that XCF files. Like I will show you 1 minute. Run that files. In the density of input file, you can see it is a tables that follow the scripts. Effective potentials, they also follow the script. So like that, every terms which follow the scripts. And now we need to show their results. We are going to import because it will take time, so we need to show that result parts. Like you can see, same AU, redefine that, again redefine that, and created that structure with that phenyl molecules. We have not created that crystal, we have just taken that. If you want to crystals are different value, you can see, and then you can move toward this density, effective transmission potential, Cbacks. You can see that results for the transmissions. We have also options to import. In previous session, we have already told about that. We have supported that formats. So I'm not going toward this. Export size are different things. I'm just going to show some of the results. Effective. It will take some time. I think open. You can see for the 2D for the like see for the temperatures. Different temperatures have ranges given. So some of the results that we have. So I'm showing you like density of states.
So
Someone asking,
I'm unable to
please ask.
quote it. Yes.
Please sir, repeat once again. I'm not able to hear you.
So
Please sir, repeat.
please step device steps. How you generate all these transmission density of states.
Okay, okay, sir. We need to again move that same projects like the device when you are created, right, sir? You need to move simulator, NanoDCAL, and analysis, sir. That tab you can see, and double click. When you double click and then click the generate file options. Okay, sir.
Yeah, thank you.
Okay. Gopal Krishnan sir asking
okay.
Yeah, please.
Hello.
Yes, ma'am.
But in between, if the job is not completed, somehow if it got exited, so is there any option to restart the
You
job
can
from the last step?
Yeah, you can recalculate that.
No, not recalculate that. Doesn't mean that from the initial step. The step, how much, let us say some SCF step it will do. Can I restart the job from the last step?
No, in here that options, if you are moving toward the NanoDCALs, it again started, ma'am. It will again start it. It not that state.
It will do from the beginning.
Yes, ma'am. It will not start in that again and again. It will start at the beginning points.
Okay. Okay, thank you.
Okay. For me, left electrode run taking running till, sir, it will take times because number of atoms more and also depend on the systems. So if you have larger systems that support it, so you can use. Why not direct run buttons? Sir, for the evolutions, we have some limitations. And how to pick XCF calculation, we have already told. And Gopal Krishnan sir asking why doing XCF calculations. Sir, Excel field calculations, it is neat because every simulation software needs some theory and their patterns. So they follow that. Because if you are not providing their hints and steps, so they're not considering what we are actually going to create and what type of property we are going to find. So we need to do XCF calculations for this. So in here that it is a 2 probe structures. We have also 4 probe structures. I'm going to show you. But it will take more time to complete. But if you are able to handle move atoms, rotate atoms, and use that buttons for create the bonds, you definitely create that type of bonds. Like we have imported that type of molecules, simple molecules from the Googles. And you can also create with the benzene form, like graphene nanoribbons are different formats you can create. You can see that's device structures. Left electrode, right electrodes. 1 minute, I will show the different form in this form. Like this. So NanoDCAL generally supported the 6 probe structures for this device. You can see left, right, bottom, top, and it facilitated the front backs. So you can move like this, and you can again create it with another bonds and another structures. Then you can select the front and back also like this. XY view or ZX view, like different. So if for the fourth probe of the structure, or not for the only AU, if you are moving towards the different one conductors, you can also check the Impulse Technology YouTube video. We are also working on this, so you can also use. We are also for the bending of device, most toward the build tabs. You can see bending of device. Like someone working on that type of project, they want to bend their structures for the both sides. For the one side, polarization angles, sign angles, like this. If I move like this, check preview like this. Many of the users also work on this. I'm just give the hints about. I'm also not too much working on this, but if someone is working, they can understand about these things like this. They can bend. If you want to bend only that one electrode, they can use. If you want to bend only that type of group box or angles, they can provide, and simply click at the build tabs. And we have also standardized cells, and if you want to create the slabs or different things, and convert to file options generally help to convert your files, like you are working Vista or anything WASP, so you can convert if they are supported. Simply browse and you can simply import. So that tabs are available. You can see that device, and if you are selected in here, that you can also check that your files are completed or not. Like this, if you click in here, if you have the crashed, sometime it may be a crashed, you can check. If you are then not showing, thanks for the using, all calculation has been finished. If you are not showing, it means that your files are crashed. You can again rerun. Don't worry about it. These things you can check again like this. They are completed, so they are showing the files are completed. If you are thinking that it is not completed, crashed, you can again move toward that XCF files or log test files, open the containing folder, and check here why they are crashed, because they can give the hints about that why they are crashed, and you can reconnect or resolve this crash issue. So not to worry about this, your cracks, why are the cracks, why are not completed. So simply clicks and simply moves toward this, right? And one more thing that I want to tell, if you want to move replace, you can go with this replace tabs. If someone want to create that defects or want to dopes and defect type of projects, you can simply replace. You can also delete that tab like this, and then you can create your device. So these tabs, it is two types. I will also tell about the tomorrow, how we can do the doping and how we can move toward the transistors. Firstly, we need to find the VI curve, zigzag graphenes. So I will explain about these things also the tomorrow. And we have different device structures. So if you have someone want to ask about these things, so please ask. I'm here to discuss about your query or any issue if you are facing. Please ask. It is open to all. You can ask. we can create a different device. Like it is one that we are simple imported that files, and if you want to move toward the new device, you want to create your new device with your own self, that tabs are also available. I hope we are able to define that examples very well, but if you want to create your own structures like left, center, and right, click that OK. In our previous sessions, we have already discussed about this. Simply import the left AU or any atoms. For the center, for the right, select. It is user defined data. You can find your data through the research papers or any points, and if you are working with, select different results and you can simulate. If you find that results are good enough, so you can follow that. And preview mismatch, generally mismatch need to be less 1%, and then you can again move with this. So it's for the device and tabs, and you can open project with existing projects, and you can save your projects, and again you want to work, you can directly work. If you want to export your project, you can directly export. So we have already discussed about these tabs. So query is open to all. Please ask if you have query related to this.
Sir, can you please just show the all these density of state, effective potential in 2 probe?
Yeah, sir, we are going to show one more time. 1 minute. With the same structures, we have already simulated that results. Like you want to say the density of states like this. You can zoom, you can export, and it will, I think, open in the MATLAB. Therefore, it is not supported. Some things that supported MATLAB, you can also directly import in the MATLAB, like projects. And it for the total electron density results for the 3D. No spin that we have selected. If you have selected the spin, it will show the difference. 2D, you can zoom, and 1D, like this. Different X memory, you can export. And one thing's transmission, like this. You can also save that files and data from here, like use your on your research papers. One more thing that we can show you, we have that tutorials like rescue. We have also the tutorial for the NanoDCALs. Device Studio also provide the tutorials. Help Device Studio tutorials. You can move, and if you move toward the rescue tutorials, NanoDCAL and NanoDCAL Plus, some tutorials are available, and some things like space grip and their things, how we can use, how we can find, you can also study about these things, so you can get a lot of the idea. Like we are working only the NanoDCAL, so you can select how we can install, getting started. You can see simple molecular structure, dynamic conductance, their scripts, how we can follow, how we can delete. So please follow that. And it's just examples, and you can create your own structures. And Impulse Technology YouTube channels also available. Research paper that we have also present for the NanoDCALs. So it's totally up to you. Now I ask anything that you want ask about the device or NanoDCALs query. Gopal Krishnan, we are asking about the transmission, scattering, thermals. So we have that transmission also. I will also show the thermal result in the tomorrow portions. So I think we need to disconnect this if someone want to ask, and otherwise we are want to disconnect this. So thank you everyone who joined these sessions. I hope you are able to understand how we can create the device structures. So please join the tomorrow sessions. We are discuss about the fourth day and another things about the device, thermal properties, modulus, and zigzag graphenes. So please join the tomorrow sessions at the same time periods, 4 to 6. Thank you, everyone.
Thank you, sir.
Okay, thank you.